What if the most important photograph in human history looked like a complete failure? We have the first clear images of 3I Atlas, the third interstellar object ever detected, and they show a blur, a smudge that refuses to focus. But hidden within that haze is a traveler older than Earth, an object moving at the very edge of physics. NASA doesn't want you to see how strange it is, but the truth is coming out. So, what secrets does this blur actually hold? Let's delve into it. Chasing motion. How do you photograph a ghost? Capturing 3I Atlas isn't like shooting an ordinary comet. It moves far too fast and shines too faintly for any normal exposure. By the time a telescope gathers even a few seconds of light, the object has already traveled thousands of kilometers. A single snapshot would show nothing but a faint, comet-shaped guess. To overcome this, astronomers had to chase it. Advanced tracking software predicted the comet's path second by second, adjusting the telescope's mount in near real time. This technique forces the background stars to blur into long trails, but it holds 3I Atlas in a fixed position on the sensor. The still soft blur you see in the final image is not a lack of focus. It's the visual record of motion being perfectly cancelled out, a precise balance struck between the comet's incredible speed and the telescope's relentless pursuit. Even for veterans like astronomer Robert Warwick, who first spotted Oumuamua, an object at magnitude 17 moving this fast is an extreme challenge. The team had to stack over 60 individual 300-second exposures just to get a coherent signal. This is less like photography, and more like assembling a ghost from whispers of light. Shape without surface. So, what does this interstellar traveler actually look like? Here's where things get strange. In the image, 3I Atlas shows no surface. There is no crisp edge, no solid nucleus shining at its center. What we see instead is an outline that refuses to stay defined, a gray body that fades into itself. The elongation is unmistakable. It is not round, and it's not a random smear. It holds a deliberate structure, smooth at one end and uneven at the other. If this were a comet from our own solar system, we would expect a classic teardrop shape, with a tail tapering behind it. But 3I Atlas shows a body that seems evenly stretched, almost like a cylinder, with no clear tail direction. This has puzzled every scientist studying it. The shape seems to hint at a rapid rotation, blurring its features together the way a long shutter turns moving water into a flat, silky surface. The team, using methods similar to those pioneered by Karen Meach for Oumuamua, detected a faint brightness variation suggesting a length-to-width ratio of approximately 3:1. This is far less extreme than Oumuamua's 10:1 ratio, but it makes the object's lack of a coma even more baffling. The absence of color. What color is a memory from another star system? When astronomers processed the raw data from the 3I Atlas image, they found something truly bizarre, an almost complete absence of color. Most comets, even faint ones, show a hint of tone, a greenish halo from cyanogen gas, or a yellowish tail from reflected sunlight. But 3I Atlas is a silent neutral gray. This lack of color tells us something profound. The object isn't actively releasing significant amounts of gas. If it were, those compounds would glow under the sun's radiation, painting the image with faint color. Instead, what we are seeing is pure reflection from a surface so dark it's estimated to have an albedo of just 0.02, meaning it reflects only 2% of the light that hits it, blacker than fresh asphalt. Planetary scientist Alan Fitzsimmons noted that while Oumuamua was reddish, this object's grayness suggests a different composition, perhaps richer in primordial carbons than silicates. Over millions of years drifting between the stars, its surface has been bombarded by cosmic rays, baking it into a material that absorbs almost everything. The color hasn't vanished, it has been cancelled out by eons of travel. Edge of certainty. How can we be sure this faint smudge is even real? In the raw data, 3I Atlas is barely a whisper above the background noise of space. When you zoom in close enough, the random static of the sky seems louder than the signal itself. But you know, the difference between noise and a real object comes down to one thing: consistency. Real light behaves with intent. It repeats, it aligns, and it holds a pattern where chaos just cannot. Across multiple long exposures, the faint streak of 3I Atlas appears in the exact same celestial coordinates. Its brightness curve remains stable despite atmospheric shifts and thermal noise in the camera. That repeatability is really the only reason astronomers can call it real. The data achieved a 5 sigma confidence level, which is the absolute minimum threshold for an official discovery in physics. As astronomer Marco Micheli, who confirmed Oumuamua's strange acceleration, would argue, a persistent signal, no matter how faint, must be treated as a real phenomenon. The final image isn't so much a photograph as it is a mathematical reconstruction, built one photon at a time until, well, millions of calculations reduce the chaos into a fragile, undeniable geometry.
Refusing form.
What happens when a discovery refuses to be categorized? Once the image of 3I Atlas was assembled, it broke every analytical model it was put into. The algorithms designed to measure a comet's coma, nucleus and tail just couldn't find a pattern. The numbers diverged, with each model insisting on a different shape. This usually means one of two things. Either the target is unstable, or the physics behind it doesn't fit our templates. The faint elongation in the image doesn't align with the direction of the sun, suggesting it isn't venting material like a normal comet. It behaves like something halfway between the rocky, silent Oumuamua and the active Comet 2I Borisov. It's too diffuse to be a solid asteroid, but too clean to be a gassy comet. That ambiguity honestly makes classification nearly impossible. Harvard astronomer Avi Loeb has controversially suggested such anomalies could be signs of non-natural origins. And while most scientists disagree, 3I Atlas adds fuel to the fire by being so stubbornly unclassifiable. The object forces us to consider that maybe our instruments were just not built to understand what this truly is.
Mathematics of blur.
When an image can't explain itself, you have to trust the numbers. The frame of 3I Atlas is too ambiguous for traditional analysis, so scientists turned to pure mathematics to reveal what the light could not. By plotting its position with micro-arcsecond precision across consecutive nights, they calculated its velocity at roughly 12 kilometers per second relative to the sun. This confirms a hyperbolic eccentricity of 1.1, the mathematical proof that it's just passing through, moving too fast for our sun's gravity to ever pull it back. Next, brightness simulations show that if the nucleus is elongated, a slow 11.2-hour tumble could perfectly recreate the uneven brightness we see. Even the blur itself becomes a measurable variable. As orbital dynamicist Davide Farnokia explains, by deconvolving the image, you can reverse the distortions and find that residual motion smear accounts for about 30% of the elongation, with the rest being the object's actual shape. The image shows uncertainty, but, the equations show precisely why it has to look that way.
Distortion or discovery.
So, is this a groundbreaking discovery or just a glitch in the machine? With an object this faint, honestly, that's the most important question. At these low light levels, distortion is just part of the data. Cosmic rays can create false flares, and tiny errors in the telescope's tracking, yet even a fraction of a pixel's worth, can accumulate over dozens of frames to create a false elongation that can be mistaken for structure. So, is the cylinder shape of 3I/Atlas real? Here's the bottom line. When independent teams processed the images using entirely different software, the same general shape remained. The angle, the brightness gradient, and the faint tapering all persisted. If distortion were the only cause, its signature would change between systems. Instead, the shape repeated itself, stubbornly and quietly, as if the comet's true geometry was asserting itself through the noise. Spectroscopist Michelle Bannister noted that even a slight reddening on one side of the blur is consistent across multiple datasets, hinting at a real physical or compositional feature. It exists on the threshold where every feature we see is a battle between signal and noise, between a real object and the struggle to see it.
Escaping definition.
At some point, the discussion around 3I Atlas stopped being about what it looked like and started being about what it refused to be. It is not a traditional comet, it has no coma or tail, it is not an asteroid, its light curve varies too smoothly to come from a simple rocky surface. The image presents something in between, a blur that resists every attempt at interpretation. Its trajectory confirms an interstellar origin, and paradoxically, that certainty of escape is the only thing about it that feels familiar. The data now paints a picture of pure contradiction, a stable brightness curve suggesting a single body, yet an asymmetry that hints at fragments orbiting a shared center. This object is defined by the fact that no existing model can describe it cleanly. As astronomer Matthew Knight puts it, sometimes an object's most important feature is its refusal to conform to our expectations. This forces us to confront the idea that seeing is not the same as knowing and our categories are only conveniences, not cosmic truths.
Between categories.
Where does this visitor fit in with the others? Our first interstellar guest, Oumuamua, was sharp, fast, and completely inert. The second, 2I Borisov, discovered by Gennady Borisov, was almost too familiar, behaving like a classic comet from our own backyard. 3I Atlas sits perfectly between them, as if bridging a gap. It's neither solid rock nor active comet, neither silent nor loud. It behaves like a memory of both. Its faint cylinder of light is the signature of something that exists just beyond the boundaries of our resolution and our taxonomy. This suggests that the objects drifting in interstellar space are far more diverse than we ever imagined. Perhaps our solar system, with its neat categories of asteroids and comets, is the real exception. David Jewett, a key researcher of the outer solar system, emphasizes that with only 3 data points, every new object dramatically reshapes our models of what's out there. 3I Atlas isn't just a third data point, it's the one that shows us the 2 extremes were not flukes, but part of a vast and largely unknown spectrum of cosmic objects.
Measured by blur.
When the light from 3I Atlas finally fades from our sensors, this photograph will be all that remains, a faint smear in an archive. In most sciences, such an image would be dismissed for its lack of detail. In astronomy, it becomes the most honest kind of evidence. A blur is what happens when the scale of the universe meets the limits of our focus. Everything measurable about this object exists inside that single unresolved streak: its speed, its path, its rotation, its distance. From this one imperfect shape, entire models of its journey emerge. We don't know what it looks like, but we know what it's doing. Soon, it will leave our system and recede into the same dark it came from, never to be seen again. This blur is not the beginning of a study, it is the end of accessibility. Paul Chodas of NASA's Kineos has stated that such flybys are fleeting gifts from the galaxy. It's the one clear record of a body from another star crossing through our home, measured by its blur. This interstellar traveler was never truly seen, only measured. Its secrets remain locked in a blurry image that asks more questions than it answers. Is it a fragment from a destroyed world, a failed comet, or something else entirely? The debate is only just beginning, and this strange, cylindrical ghost will haunt astronomy for decades to come. Its existence proves that the universe is not only stranger than we imagine, it is stranger than we can imagine. What do you think this object really is? Let us know your thoughts in the comments down below. Don't forget to like, subscribe, and hit the bell icon to stay up to date with all things 3I Atlas. Thanks for watching Space Facts.